Welcome to the Industrial Edge podcast with me, Joe Haggis. In this podcast, we sit down with a broad range of professionals who are involved in a wide range of industrial settings. From maintenance and reliability professionals, facility managers, engineers, through to operations and production leaders, consultants, and business owners who support all things that keep the modern world we live in safe, productive, and efficient. We discuss the unique stories our guests have been on personally, while getting into some of the deeper details, challenges, and opportunities that face them in their particular industries and areas of specialisation. I hope you enjoy the conversation. Welcome, Erik. We've got Erik Hupje, who is the founder of Reliability Academy. Erik, I was actually looking back at some emails that I sent to you 8 years ago now, 2018. I sent you an email because you were in Australia at the time. I was still in the UK. And you gave me some great advice on moving to Australia, what to expect, what the job market looked like as well. So I've followed your journey for a long time, as you know. I interact with a lot of your content and you know, I think your content is fantastic. And I love the approach that you take around, you know, making reliability simple. You've even got that trademark, which I think is fantastic. But I really look, you know, and really, as I kind of went on my journey, especially over here in Australia, you know, as a maintenance supervisor, maintenance manager, I really resonated with a lot of your content, and I still do, right? So first of all, I want to say thank you for putting that good content out there. I know you obviously you know, provide training as well to companies as well. So first of all, thank you for all the content that you've put out there over the years. I just wanted to say that at the outset. But first question for you, Erik, is what is one view that you hold that is most often misunderstood or pushed back against in maintenance and reliability?
I think the important one is that, going back to what our trademark is that making reliability simple. It's not maybe actively pushed back with, but you routinely get people, yeah, but it's not that simple. You know, we're different. It doesn't work like that here. So I think it's maybe not actively and openly pushed back on that much, but very often there's an undercurrent where people go like, yeah, but that's too simple, it won't work here, etc. But when in reality is that it does pretty much work almost everywhere, right? So when it comes to improving reliability, especially for plants that are still in the reactive space, which is what I focus on in terms of working with clients and training, it's really those foundational processes that really make a big difference. And those aren't as complicated as people make them out to be, and you do not need a 20-element framework to make a real step change in your reliability performance.
Yeah, nice. I think it's, again, I always like, again, with your content and the work that you do, right? Again, it's all grounded in making it simpler, not making it more complex. It doesn't need to be, like you say, a 20-step framework that, you know, you need a PhD to understand, should we say. So I really like the simplicity. So no, that's good. Take us now through, you know, I like I say, I know your journey, should we say. I've heard you speak about it in a few other podcasts, but for everyone else that might not have listened, you know, you predominantly spent your time in oil and gas. You spent a lot of time with Shell and then Arrow Energy in Australia. Do you want to just talk us through, you know, those early days in maintenance, you know, some of the highlights of your career and leading up to the point of, you know, launching your own business in Reliability Academy?
Yeah, sure. So I'm originally from the Netherlands, right, which explains my funny accent. And that's where I joined Shell in, what was it, 97. So that's a while ago. Went to the UK, worked 4 or 5 years in the UK offshore, onshore, offshore assets. Spent time in the Philippines for a major offshore platform there, onshore gas plant. And over the years, basically, you know, worked in a range of roles. It was in the Philippines where I moved to, where I ended up in maintenance. I was actually due to go into a project engineering role, but the project fell through, didn't hit the economic hurdles. And so the asset manager said, "Hey, Erik, can you go have a look at maintenance? It's not really going that well. We're spending a lot of money. The reliability is not what it needs to be." And I said, "Well, I don't know anything about maintenance." He said, "That's okay. You're a smart guy. You'll figure out. Go have a look and see what we can do." And that's literally how I ended up in maintenance back in early 2000s. and starting to look at maintenance improvement, PM program, availability, reliability issues, and everything else. A couple of years later, a year and a half or 2 years later, I took over as head of maintenance execution there. So responsible for the execution of all the maintenance offshore, and at the onshore gas plant. And that was probably kind of the defining, in many ways, a defining role for me in my career. That was really when I got my hands dirty in terms of maintenance. And it was the offshore platform that was really quite a pain in the backside, to be honest. We had pretty much every day of the week, we had a new emergency job, and we had a lot of reliability issues. We had a lot of integrity issues. We had a lot of outstanding critical maintenance. And so that's where it really became quite a struggle to figure out, okay, how to solve this. And I remember reaching out to the market, saying, okay, how do I do this? Because I was relatively new in maintenance at that point. And everything I got back from the market was really complex, really expensive, multi-year journeys. I still have one of the models that somebody gave me. It was a 3D pyramid with 20 elements on each side. It says, you got to implement that. And I went like, there's no way I can implement that. So, reality forced a hand, and it was like, hey, you've got 59 beds on that offshore platform. You need to get all this work done. We've got to get more efficient, right? We've just got to focus on getting more efficient. How do we do that? Well, planning and scheduling. So we started focusing on planning and scheduling. We implemented that with the team and drove it into the organization. And then we started improving the PM programs, adding RCAs and defect elimination. And that's kind of how I, more or less by accident, discovered the framework that I now use with clients. And then later on, years later, I discovered that there actually was research that underpinned that, the research that Winston LeDay did that led to the development of the manufacturing game. They found that they benchmarked 140 plants around the world, Europe, Asia, and the US, or Japan and the US. And they found that typical reactive plant had 83, 84% uptime, but the best in the class were achieving 98%. And what was the difference? Well, they were doing planning and scheduling and good preventive maintenance and defect elimination. And so that's what we use with our clients. It's what worked for me in the past. It's what worked for me in other roles. And the research also proves it. And I think it's actually that research from Winston LeDay is, in my view, highly undervalued in industry at the moment. I know it's a couple of decades old, but the principles still apply.
Yeah, nice. And why do you think that is? Maybe around that, that Winston LeDay study and documentation. Why do you think that is undervalued? Maybe.
Well, there's a couple of things. One is I think obviously it was done for DuPont, and I think it was done by A.T. Kearney at the time, so it was kind of proprietary research. But he wrote, over the years, he presented at various conferences. He's written a couple of books, but it's never really gained as much publicity or traction as some of the other material. And I think, if I'm really honest, it doesn't sell very well, right? Keeping things simple and simple framework, focusing on three things, it doesn't sell. It's a lot of companies have a lot to gain by selling their frameworks and their software and everything else. So, and it's a very noisy marketplace also, right? If you think about it, if you go online, there's, especially now with AI, there's more and more content out there. It's not necessarily all good content, but there's more and more content out there. There's a lot of big frameworks. And don't get me wrong, the frameworks you see from some of these organizations, they're not wrong. I mean, theoretically, they're all correct. The problem is that most plants around the world are not ready for those kind of frameworks, because the frameworks are aimed at achieving world-class performance. Most plants are nowhere near world-class. They're struggling to make the beginning, right? And when you're in the reactive mode and you want to get a lot better, you don't need 20 different elements. You need to focus on the 3 or 4 that really matter.
Yeah.
Yeah.
No, it's good. And like you say, they're built around a world-class framework. Most places, like you say, aren't ready for world-class and probably don't need world-class, right? A lot of places.
True. Yeah, absolutely.
Yeah. And I think, like you say, when you build a framework that is, aspiring to that world class, it's not kind of getting to you. It's not outlining, hey, what do you need to get to this sort of minimum acceptable standard that fits with your organization, fits with your objectives in your organization as well, right? So, yeah, really good points. Erik, just moving on to, so again, talking about your framework, and again, very simple. And like you say, right, maybe many consultants out there want to sell a big, large framework with 100 slide deck on how to, coaching you how to implement that big, complex framework, should we say. Your framework is simple. It's got four elements to it. We're gonna maybe go through some of those elements. We're going to start with planning and scheduling, because I think as you mentioned, that is really the key and the foundation. I think it's fair to say one of the keys. But if you do planning and scheduling well, you can become much more effective in your maintenance execution and strategy, right? Why planning and scheduling, Eric? Because in my experience, I've seen a lot of companies, one, get them mixed up, planning and scheduling. They call them someone a planner, but they're actually a scheduler. And in my experience, again, I've not seen many plants, and maybe this is the industries I've worked in, not seen many places do planning very well. I've seen them do scheduling quite well, let's say, from my experience. But I've not seen many organizations get the planning piece right. Why planning and scheduling? And can maybe you go a little bit deeper into the planning area of that?
Yeah, sure. So, point one is indeed planning and scheduling is very foundational because it's basically it helps to create a more stable working environment. It helps to create a more efficient and effective working environment. So it's really important to get in place. Um, and we typically recommend that this is where organizations focus on for a number of reasons. We can come to those later. In terms of why planning and scheduling, well, basically, um, they're very different things. Right, but you need to do both. They're part of the kind of a work management process that starts with the creating of a notification, planning the work, scheduling the work, executing it, closing it out, right, and then reviewing and improving performance. The planning piece is basically saying, okay, what do I need to do? And I'm going to get that done. So making sure that a technician, when the technician starts the job, he or she has everything they need to do the job, to finish the job efficiently and to the right standard, right? So that means parts, materials, job steps, procedures, testing requirements, external service providers, scaffolding, rigging, welding, whatever you need to do the job, all that needs to be identified and it needs to be in place so that when you start the job, you can finish the job without delay. That's what planning is all about. Um, and this is why we'll come to it maybe also a bit later, but this is why you typically need to have planners who understand the job that they're planning. They typically need to have a trade background for the work that they're doing. So asking a mechanic to plan electrical work is usually not going to work that well for those kind of reasons because he or she has never done it and doesn't really understand how it needs to be done and what is required. The scheduling piece is about coordination. It's about making sure that you group work efficiently, making sure that when the mechanic rocks up to go and overhaul the pump, well, the process isolation by operations has been done, the electrical isolation has been done, the scaffold is there, and the lifting is all in place. So the mechanic can go and do what he needs to do without having to hang around for 4 hours for all that to be done first, right? That is what the scheduling is about. Plus, the other big part of scheduling is the grouping of work, so that you can say, hey, I'm going to take that pump down, I'm going to do major service on it or whatever it is. And you go like, oh yeah, but while I'm there, I better go make sure that the motor gets done and I've got to do that relief valve and I better also do the trip transmitter because all that needs to happen at the same time. Otherwise, I'm going to shut down that pump 4 times in the next 3 months, which is what happens in a lot of organizations, right? So they're very distinct processes or functions, and they require different kind of capabilities, and they've got to work together. I think it was Doc Palmer who wrote in his book that planning is about reducing delays during jobs, and scheduling is about reducing delays between jobs, right? So that's the difference, and that's really good. You're right, absolutely. I see the same in the sense that a lot of organizations, when they say they're doing planning and scheduling, they're typically doing a lot of scheduling, and they're doing very little planning. I see that coming through in different industries, whether it's in mining, oil and gas, or chemicals, or manufacturing or ports. I see that coming back again and again. Um, Big part of that is because I think a lot of organizations don't really understand the difference between what is planning and what is scheduling. And in common day-to-day talking, we often use them almost as synonyms, right? If you ask somebody for a plan, they'll show you a Gantt chart, which is really a schedule, right? They're not going to show you step by step exactly how to do the job and everything else. So that's part of the problem. And I know in some organizations, for example, when I used to work in Shell, there was so much confusion about planning and scheduling also because there was another process called integrated activity planning, which was much more about the scheduling work. There's so much confusion about the word planning that they dropped it and they started adopting work preparation to make clear, say, hey, this is about preparing work for efficient and effective execution. That's what the role of the planner is. Um, And so, yeah, what you see happening, I've seen it here in Australia also in a number of sites, where they fill the planner role with somebody who doesn't have a trade or a technical background and therefore can't actually prepare the work. And guess what happens? No disrespect to them, they're trying to do their best, but they then almost become a postbox, because what happens is if you need to overhaul a machine and you've never done that work, you don't know really even how that machine works in detail, you now go and ask the maintenance supervisor or the technician, say, hey, what do we need to do that overhaul? What parts do I need? What are the steps and everything else? They provide that, and then the planner ends up sticking it in. So what happens in quite a few places, where they say we do remote planning or we have planning centralized, really what that means is they've pushed planning back into execution and they've got somebody centralized who's typing it into the system. Yeah, so what I was saying, what I've seen is quite often indeed you have people in a role who don't have a trade background, and then what happens is they pass on the planning requirements to people in the execution team, right? So you have somebody who doesn't have that trade or technical understanding, and therefore they then ask the planner, or sorry, the supervisor or the technician, say, hey, how do we do that job? What are parts are needed? How long is it going to take? What do you need? And so now we've got execution people actually planning, passing it back to your planner, who then types it into SAP or Maximo, right? And there's some really big companies in the world, here in Australia, who centralize planning, but I've seen them also do it in the oil and gas, in Europe, who centralize planning, but all they're really doing is they're centralizing data entry, because the planning still is actually happening by the front line now, who then have to send it through emails and everything else, and then the planners put it in. That is not what planning is intended to be,
Yeah,
at least
brilliant.
not in my view.
Yeah, no, I completely agree. Right, I think you're basically doubling your workload there if you're not being really clear on who does what. And you're taking time away from maintenance, technicians, supervisors, mechanics, from actually doing what they should be doing, which is executing work at the end of the day, right? And that maybe leads into my next question, which is around wrench time. I know you use wrench time, and a lot of the time maybe it's a good tool to really expose waste, right? I think that's fair to say. Um, have you seen wrench time actually be genuinely used effectively? Again, I'm not sure if it's maybe the industries I'm in, more maybe it's been more sort of logistics, warehousing, automation, those sorts of industries I've been in. Um, but wrench time, do you use that as a tool maybe to expose that waste and really to highlight, or do you find it? What's the use out of using a wrench time calculator? Do you find, and has it still got a place? In this day and age, should we say, in terms of going to the Excel, inputting the data, or can we maybe get I'll say AI to do some of that for us, or a tool to do that these days? What does that look like?
Yeah, well, there's a few questions there. I guess we can talk about the tool later, but so first things first. So wrench time is, like you say, it's all about waste, right? And exposing waste. And I know that there's sometimes people who go like, oh, wrench time is such an outdated concept. It comes from, John Ford and the Taylorism, and it's like last century. Yes and no. Wrench time, if you treat it like Taylor or Ford, and you have this very negative approach, yeah, then it's not going to work. It's going to upset a lot of people and everything else. But wrench time, really, the way I look at it, it's just about waste. It's just about exposing waste in your process, right? So I try to avoid the word lean. But that's really what it is. That's actually almost everything I do with the clients, and everything I teach is about eliminating waste through planning and scheduling, eliminating waste through improving your PM program, eliminating waste through defect elimination, because, repeat failures are a form of waste as well. I don't call it lean, because lean, certainly in oil and gas, had developed a very bad taste because they focus very much on tools rather than the underlying processes and everything else. But wrench time is all about understanding where the waste comes from. And it is really important that organizations look at this, understand that waste is not because people are, usually not because people don't want to work, right? If you look where a typical technician spends their time, out of a 10-hour day, probably about 3 hours is productive maintenance time, and the rest is lost and all kinds of other stuff. And it's not because they're not working hard, it's because the system has made it hard for them to be efficient. They're waiting for permits, they're waiting for tools, they're waiting for materials, they're looking for additional materials. The isolation is not on time. The scaffold is wrong and that needs to be corrected, and they can't start. There's dozens of reasons why people end up losing time, right? And so the concept of wrench time is just trying to understand, okay, what are our biggest sources of waste? Is it the permit issue in the morning? Is it the fact that we have to go and stand in line to collect materials? Or is it that our job plans suck and basically half the time the job stops and we have to go get instructions and go get the materials? That's the value, right? And so my view on wrench time is that it's now maybe more important than ever before, because most companies are very tight on resources. They're struggling to maintain their technician pools and everything else. So it's really important that we're efficient with the labor we have, and that's what wrench time helps with. It is not a KPI. There's no point in trying to track wrench time on a daily basis or a monthly basis, in my view. Vast majority of organizations will never be ready for that, and it's also not needed. It's something you do on a at a certain frequency. You do an initial assessment, and the first initial assessment usually doesn't have to be very detailed either, because guess what? Usually the wrench time is pretty poor. I can walk in, people who've got a bit of experience can walk into a plant, look at it and go like, nah, I think your wrench time is about X. And then you can go detailed study and it'll be pretty close to X. So do a quick assessment, and you'll find that your wrench time most likely sits somewhere between 25 and 35%. And then look at, okay, well, where's the waste going? Is it the permits? Is it the isolations? Is it lack of planning? Is it material issue? Is it travel at site? Whatever it is, tackle those sources of waste, and then 1 or 2 years later, do another assessment, and then progressively get better. So I think it still has a very important role to play, because it's about eliminating waste. But it is important that the organization who's working with it understand that it can have negative connotations depending on where you are in the world, depending on how you frame it. And it's important that you approach it that, that waste is not because of people usually not wanting to work. It's because of how the organization has made it difficult to work efficiently.
Yeah, nice. And I think, attacking the system, right, and the processes that you've got, as opposed to the individuals, right? Like you say, that 99.9% of people go to work, they want to do a good job, and for a lot of
Yeah.
technicians, they actually just want to get on with the work, and they're more
Oh,
engaged when
yeah.
they're doing the work,
Yeah.
right?
Yeah.
They don't want to be
Yeah.
back and forth, filling in permits, this and that. They want to just be out there doing their work, right? So, again, it comes back to good planning and scheduling, like you mentioned. Again, improving that to increase your productivity. But again, there's so many other benefits that, again, we could spend a while talking about. But again, more engaged people, you're more effective, et cetera, et cetera. So there's so many benefits. So no, really good. Eric, talking about maybe a bit of a similar question in terms of planning, scheduling, but more around like organization. Building, and the question I've got here is building a maintenance and reliability team from scratch. How would you approach that, and how have you done that in the past? And at a very high level, we don't have to go super into the details, but how would you guide someone that's starting up a new site on setting up their team for success? What are the key roles in there? Is there any sort of ratios, or is it not that complex? How do you approach that holistically? I know it's a big question.
Yeah, it's a big question. I'm just trying to think how I'm gonna break that down into something simple. You know that I have to keep things simple, otherwise my brain doesn't work. I think step one, take a step, go all the way back and say, okay, what is the asset we're dealing with, and what is the maintenance philosophy, right? Because how you set up an organization really needs to be reflecting that, what the type of asset is, what the maintenance philosophy should be, and that needs to be linked to your operating philosophy and the value of downtime and everything else. So, how you structure how you set up a refinery with 500, 600 maintenance technicians versus, uh, in a on the coastal locations versus a remote mine versus an offshore platform versus a manufacturing site or a food plant and everything else, that is quite different, right? So you need to understand, okay, what is the philosophy? How do we run this asset? What are the requirements, and how are we going to basically deliver on that? So that is really important. And actually, I think a lot of organizations don't have real good clarity on what their maintenance philosophy is, and why their philosophy is what it is, right? What drives value, and therefore, what do we need to have? Because not all organizations need to have 97, 98, 99% uptime. right? If you don't run 24/7 and your production is say on batches, or it's only day shift or whatever it is, then there is probably not a huge amount of value in trying to push that reliability and availability to very high levels, right? So there's trade-off to be had, and you need to be clear about where that trade-off is, and should document that so that people actually know this, so that when the next person comes, they understand this. Um, all that said, go back to some of the foundational processes, right? So if you look at our framework, what are the things that are in there that need to happen? Well, you need to have good planning and scheduling, which means you need to have somebody who is planning and somebody who's scheduling. Typically, you want to split the role, and typically, if you can, it depends on the size of your asset, you want to have your planners by trade, because getting a mechanic to plan E&I and mechanical is tricky, to say the least. But you need to have planning and scheduling. You obviously need to have execution. So technicians, an important decision is, okay, how much do you insource? How much do you outsource? That on itself can be hours conversation, but it's
Yeah.
important to
Yeah.
have a very conscious decision about that. And just the one thing I'll say is, be careful with how much you outsource, because what you find, and multiple organizations around the world have found this, if you outsource the management of maintenance, one day, 3, 5, 7 years down the line, you will wake up and you realize that you're not happy with the performance of your contractor, and now you have nobody left in the organization who can actually understand and manage maintenance. So you've got to really be careful how much you outsource. So typically, I'm a fan of making sure that the management stays with the company, most of the planning and scheduling stays with the company, and you have part of your technician pool is your own technicians. But there's reasons why you sometimes adopt something else. So that becomes a big part. And then, so that's around the execution, the planning and scheduling. You need to set up some kind of maintenance reliability function that builds your PM program, because I mean, your PM program is foundational to achieving your required availability and reliability targets. And therefore, you need to have somebody in your organization, or multiple people in your organization, who understand that, who build that, who can operationalize that into your CMS. And the key thing there is, they understand some of the principles of reliability-centered maintenance, right? We keep seeing again and again and again PM programs that are built by people who are maybe more design engineers, and have never really kind of been exposed to those reliability principles, and therefore build PM programs that are overly conservative, bloated with tasks that are not really fit for purpose, and et cetera, right? So you end up with a PM program that's pretty poor. So that's really important. You need to have somebody there who runs the PM program, and you need to have somebody in your organization who's looking at root cause analysis, and eventually defect elimination. So you're basically looking at, hey, okay, what is happening? What is working? What's not working well? Why is that not working well? What do we need to do to fix it? Make sure it happens and it fixes it, right? How big and how complex you make that really depends on the size of your organization, right? But that's kind of where I would start. And of course, the key thing here is start this early on in the asset lifecycle, right? So if you look at the asset lifecycle, when you're doing the conceptual design for your plant, this is when you want to have already your first maintenance guy, potentially your future maintenance manager on site, who starts thinking this through and preparing the organization, drafting the philosophy and all this kind of stuff. And then when you're going to construction phase, that's when you start ramping up the hiring of your maintenance team, your maintenance techs, your future planners, your schedulers, etc. And they start building your PM program, your asset register, populating your CMS, all those kind of things. So by the time you start up, you've got your CMS with all your asset register, you've got your bill of materials, you've got spares in the inventory, you've got your PM program, all those things are in place. Unfortunately, that doesn't always happen. And so you see a lot of sites around the world that start up, they've got a maintenance team that's just about rocked up the day after the site starts. And they don't really have a good PM program, or maybe sometimes even no PM program. They've got barely any parts, and so now from day one they're behind the eight ball, if you will, in terms of building all that while they're trying to run a plant and maintain a plant.
Yeah, it's a really good, it's a great point you mentioned around operational readiness, or again, like, in terms of a plant getting ready. I think not investing at the outset, and again embedding your maintenance team within, as you start that process. it's a very slippery slope, right? Because again, like you say, maybe sometimes that there can be a misconception of, well, it's brand new equipment, it's a brand new site, so why do we need why do we need lots of maintenance people? Should we say, right? Let's say holistically, the view might be from someone from finance, let's say, arguably, but the value of that, like you say, getting those, getting your assets captured, getting set up, setting the team up for success, understanding and making sure, first of all, checking the actual the installations right and the quality of the installations right. They understand the processes, especially in complex sites, like you say. It's absolutely invaluable, and that really sets them the foundations and sets them up for success, right? As opposed to, here are the keys, we're done now, off we go. And again, making sure there's a smooth transition. It's not just a straight line, should we say? It's got to be a phased handover from construction to maintenance. So no, really good points. I have got a question here around about early asset life cycle and around setting up for success. I think you've outlined it there, but I think you mentioned it already. I was just saying, Erik, about early asset life cycle, but around maintainability. Do you see, are there many businesses or clients that you work with out there that are doing this well in terms of getting people focused on? I know in some industries it's called reliability, availability, maintainability, but have you seen businesses do that well in terms of really embedding reliability, I suppose, first of all, into maintenance and into design, sorry, and also looking into the maintainability of assets. How easy access is the isolator in the right place? These sorts of things. Have you seen businesses do that well in your experience, or is it still an area of big opportunity for companies?
Well, both. I think for most companies, it's a massive area for improvement. But I have seen businesses do it well. I've been in projects where, to be fair, we've done it well. With a number of things. So basically, when you're doing your design, you have like a 3D model review where you look at maintainability. You have a whole clear set of criteria of, hey, if you put this kind of equipment in, this is what you need to provide, for example, in access. And then you actually have a 3D model review where you say, okay, this is the compressor or the motor or whatever, and we're gonna, these are the tasks we need to do over the life cycle. So show me how we're going to access this. Show me how we're going to remove this. Right? You do a mechanical handling study for your major equipment so you can take them in and out and everything else. Doesn't mean that you have to build everything into the plant. You may well do your mechanical handling study, say, hey, we're only going to do this once every 8 years, so we'll do it with a crane and we're going to lift the roof off. And you go like, well, okay, fair enough. We'll just have to, you can't
Yeah,
build
of
everything
course,
into the plant, right? So
of
there's
course.
a value trade-off. But if it's only done every 8 years or whatever, you can accept that. So yeah, you do your 3D models review, you can do your mechanical handling study, all those kind of things in terms of maintainability. And then what you really want to do, especially with kind of large continuous industry like oil and gas or petrochemical facilities, is build a RAM model. That is a big thing. And basically what you do there is you build a model that replicates the facility and the design, and you basically add in data around failure modes and likelihood of failure modes and everything else, and you can make a forecast of your ability to deliver your production targets. So I've done this a few times now over my career for assets, and it's actually pretty interesting what you can achieve with those things. And it's very, very insightful in terms of helping to make right decisions around sparing strategies. And now even when I say sparing strategies, I mean like redundancy, but also the next step, once you build a more detailed model later in the project, you can actually use it to determine your capital spares and your operating spares, etc., based on that data. So that's really valuable. The great thing about those things is if you build that in conceptual phase, it helps you to make good design decisions. Then you go into the more detailed phase, you add in more data, and it really helps you to kind of fine tune your production targets and your reliability targets. And then once you're in operating, what you want to do is you want to go back to your model and feed in your actual operating experience and say, okay, well, what should we be able to achieve given that we now have this operating data, this failure data, and you can fine tune it and you can use that to set, meaningful reliability targets. So, yeah, I've seen it done. And I've seen it done well, but it's not very common. And the other thing is that whole RAM modeling piece is pretty bespoke and a niche kind of skill set. There's not many people out there who can do it well.
Yeah, nice. And is that around, from my understanding, that's around, like you say, I suppose understanding criticality, but also, where you've got redundancy, where you maybe you want to add in redundancy if again based on, is it based on criticality, that is that, are you explaining there? And again, I'm certainly not an expert on this. Is that around like reliability block diagrams in terms of that sort of, is that what you're explaining there for people that might
Yeah.
not be aware?
Yeah, exactly. So basically the software, in the software, you build a reliability block diagram, and you start with a relatively simple one in the conceptual project or phase, the conceptual phase of the project. And reliability block diagram where you put the different equipment in with the failure modes and the likelihood of those failure modes, and then the model basically starts calculating some. And then as you progress, you add more detail. Yeah,
Yeah,
and
nice.
that helps you to make kind of good assessments. Like I say, okay, well, because what happens if you think major projects, you make predictions or around in your economics about, okay, we can hit this amount of production. Well, unless you build a model that tells you can indeed achieve that, it's guesstimating, right? Because you're doing the engineering design, and that tells you what your plant is sized for, and you have your economics. But if you don't build a RAM model, you're actually not bringing those two together.
Yeah, absolutely. And like you said as well, you mentioned as well, that informs a good spare strategy. You're not over ordering spares, where you don't need to be, right? Or again, you at least have a really good understanding of what spares you should be holding based on the criticality, redundancy that you have, but also like you mentioned before, how often are you going to be likely to be doing that task as well, right? And do you need to have a nice way to easily be able to get that motor or pump or whatever that asset may be out, or do you need to take the roof off, should we say, because it's going to happen once every year. So and coming back to the other points, lots of trade-offs, right, in terms of, and it's about balance, right? It's about balancing and taking a risk-based approach is what I'm getting from you. And also around, again, like you say, eliminating that waste out and to kind of sum up that sort of part there. Erik, go now into, I'm going to go into defect elimination. I'm conscious of time. I've spent probably too much time on planning, scheduling, early asset lifecycle, but that is a big part. But moving now into, let's go into defect elimination. Again, you focus on the basics, making reliability simple. Again, I love that you've trademarked that because it's such a good phrase of just what you are about. But yeah, and I think these are all words, and I think again you might have mentioned these are from the DuPont study, etc. But 80% of failures that occur in a plant have occurred before. Fix them forever and stop forever fixing. I think that was, again, shamelessly stole that from one of your posts, but there's still, I find, a lack of understanding around that concept. And also, maybe I'm adding to the question, but similarly, 80% of failures are random, right? They're not age related, and there's still that misconception out there. But coming back to the question, why is defect elimination so important? Can you explain that in a little bit more detail? Again, using that sort of word, 80% of failures that occur in a plant have occurred before.
Yeah. Indeed. So the vast majority of failures you deal with in a plant have occurred before, not only because we're not necessarily very good at fixing the problems properly, and so we keep fixing the same failure over and over, but also in most industrial plants, you don't have one pump. You have 10 pumps, you have 100 pumps. You don't have one transmitter, you have 100 or 2,000 or 10,000, depending on the size of your plant, right? So that's the other reason why we have so many repeat failures, because we have, well, so much of the same equipment, right? So if one failure happens on one, it's likely to happen on something else. Um, and so we've got to keep in mind that not all not all failures can be prevented through maintenance. In fact, there's a lot of failures out there that have nothing to do with maintenance, right? They're the result of poor design, operator error, maintenance error, poor quality of materials, whatever. There's heaps of different reasons why, but it still leads to failure. Now, if it's poor design, you can go maintain that pump every month, but it's not going to change the design issue, right? You need to resolve that design issue. So there's lots of defects in all the different plants that we have. And so if you want to become more proactive, you want to become more reliable and get less reactive, you basically need to address what is causing those failures, right? And that's what root cause analysis and defect elimination is about. And people often kind of misunderstand the difference. Um, I use the phrase defect elimination because that's where we want to get to. But in reality, for most organizations, you've got to start with root cause analysis, which is the bad actors, the big problems, right? Quite a few organizations do root cause analysis. They don't necessarily do it very well, and they often don't have a very structured process. And a common problem we see is heaps of analysis and not much implementation. And so you don't actually get much benefit. A typical organization, you walk in, they've done 20 RCAs in the last so many, whatever, months or years, but they still have 100 actions outstanding because they haven't had the capacity to execute for lots of reasons. And so that's really important. But you've got to basically get those defects out of your plans. Otherwise, you'll never stop those failures from occurring. So this is why it's so important. And if you look at the research from the manufacturing game from DuPont and Winston-Lede, that showed that the impact of defect elimination is the biggest of the three processes, right? But you cannot jump to it. You cannot jump ahead. That's the other thing people keep asking me, say, well, if defect elimination is the biggest one, why don't we just start there? And the thing is, to do good defect elimination and do good effective root cause analysis and build that into your culture and sustain it, you need to kind of have gotten out of the worst of the reactive mode. Because when you're in a very reactive plant, what typically happens is that you've got way too much work. You are not very efficient because you're firefighting. Therefore, there is quite a lot of stress. There's a lot of pressure. You're missing production targets and everything else. So there's the stress. And all that tends to then drive to quite often quite a strong blame culture. And once you have that, it becomes really difficult to actually do thorough analysis of, hey, why did this fail, and what are the systemic issues that we need to resolve, right? Why did this fail? Because Joe didn't do it properly, right? That's very quick, it's very easy, it's very direct, but that doesn't solve really the issue, typically. And so you need to build first a certain level of stability in your organization so people can actually get into the mindset of really tackling underlying issues. And that's what root cause analysis and defect elimination is about. And then over time, as you do that, you get better and better, because what happens in a lot of organizations is something fails, especially in reactive organizations, something fails and they get good at fixing the same failure, right? We put in special procedures, we increase inventory, we sometimes even have dedicated teams to deal with break-ins or breakdowns, instead of actually saying, hey, what is underlying under these failures, and let's get rid of those root causes.
Yeah, stop. Fix it forever. Stop forever fixing it, right? And like you say,
Yeah, absolutely.
The challenge is we start getting good at, that pump's failed again. We're quick now. We can get that down to 45 minutes, and that's what
Yes.
people start chasing, which isn't the right thing to do, right? It's about, the pump shouldn't have failed in the first place, or we should at least been able to catch it before it did fail, or like you say, engineer the issue out, prolong the life of it, etc. No, brilliant. Erik, I'm going to go to the other section of again of your framework, talking now about leadership and culture. We've already talked a little bit about team structure, setting up for success, and again that as you outlined, that depends on your operational philosophies, and you've got to align to that, right? It's you've got to be really really aligned to that. Otherwise, when there's misalignment, you'll either be under maintaining, over maintaining, and that's not healthy, right? But in terms of leadership and culture, what's the question I'm asking here, Erik? First of all, the importance of leadership on on that road to reliability. How important is that of setting up yourself, your team for success? Is it the key, would you say, or can you have, can you get by on, let's say, a maintenance manager that is pretty average, and you have some superstars in the team? What's the importance of leadership and culture?
Yes, I think leadership and culture is really important. That's why it's in that framework, right? So we focus on the three foundational processes of planning and scheduling, preventive maintenance, defect elimination. But you need leadership and culture. Typically, the way I explained is you need leadership to start making that journey. You need somebody somewhere in the organizations to start saying, you know what, I'm sick and tired of working like this. We're going to do this differently. There is a better way of doing it. We're going to start driving that. And you need a driving force. And that's what somebody needs to bring that leadership to the organization. And early on in the journey, it is very much about pushing. right? That's where the leadership is required. But what is needs to happen fairly soon afterwards is you need to start working on your culture so that the improvements you're making become your way of working, right? And so, you routinely reemphasize the importance of reliability, the importance of certain practices, the importance of certain processes. And you need to make sure that you have clear documented processes and procedures. You need to make sure that you reward the right kind of behaviors and you deal with the wrong kind of behaviors. So next time that pump fails and guys are working till 1 a.m. overtime to fix it, you say thank you, but you don't give them a bonus. You give them a bonus and a more public thank you when they've done the RCA, right? So you move your incentives away from the reactiveness to the more proactive. So you start building the right, or embedding the right things in the organization through culture. That's really important because if you don't do that, you'll never sustain the improvements you make.
Yeah,
So that's
absolutely.
the idea. That's how I see the difference between leadership and culture, and why they're both so important. Now, culture is often culture is a kind of a fluffy thing in many ways, and there's lots of books. Well, lots. There's a few books written about. Probably not actually. Lots of books written about culture, organizational culture, corporate culture, and there's even a few books around reliability culture. But all of them are still fairly abstract, and so one of the things we try and do is work with the clients and say, hey, let's just make that very actionable, right? And you can. So if you think about you can build a very simple framework and very simple practices, say around planning and scheduling. A common problem in lots of organizations is say the work requests coming in, right? So it's poor quality work requests coming in and poor prioritization. And so you've got bad quality work requests that are breaking into your schedule. Happens all the time. 30-40% break in is quite common in heavy industry. Um, you need to fix that, and so you basically need to install a proper process. But to embed that and to sustain it, obviously you emphasize the importance of the prioritization, but you can also set up a simple mechanism where you reward operators and technicians for the best notification of the week or whatever, right? And so you start driving that kind of right behavior for, hey, I want to see good quality notifications, therefore that's what I'm rewarding. So yeah, it's a really big part of sustaining the journey. The one thing I would say though is a while back I did a survey on LinkedIn and we said, hey, what's your biggest pain point when it comes to your reliability journey? And I think 52% said lack of leadership support, right? So it is a common pain point. But I think one of the problems I see or I feel is that in a lot of organizations, approach reliability as this kind of marathon journey where they say, it's a marathon, not a sprint. And I guess that because I get that because it is a longer term journey. But the problem is sometimes we frame these reliability improvement plans too big, too long, too expensive, too comprehensive. We try and put everything in there, and it's a 5-year project when we try and tackle 20 elements and everything else, right? And the result is big upfront expenditure for a yet to be seen reliability gain in the future with associated gains in production and cost reduction. And that can be a very hard sell to leadership especially when maintenance and reliability are not, doing so well. To try and then sell that picture is difficult. So one of the things we try and do is say, hey, let's just make it simpler. Let's go back to the core processes. Let's just first focus on planning and scheduling. And you don't need that much leadership, executive leadership sponsor. Yes, it certainly helps. And I would always try and push for it strongly. But you'd be surprised how much you can achieve if you are a maintenance superintendent in the middle of the organization by just focusing on the right maintenance planning and scheduling practices. And you can drive a lot of improvement. Do that for 6 or 12 months, document the benefits, and then come back and say, hey, look, this is what we've achieved. Now we want to go and do something around the preventive maintenance program. And then eventually you get to the defect elimination. So cut a long story short, yeah, leadership is really important, but it doesn't have to be top leaders who drive this. And I think we have to make sure that we don't hide behind it. There's a lot you can do even at the lower levels and the middle levels of an organization.
Yeah, absolutely. And again, it doesn't have to be, like you say, it doesn't have to be, whilst it massively helps if your maintenance superintendent, your maintenance manager has that clear vision and could provide that support. It doesn't need to be, it always helps, like you say, to get an executive to sponsor. And if they're supportive, then it makes it easier. But the way around that, if you don't have that, is around those quick wins. I say quick wins. starting somewhere, right? You're not trying to boil the ocean,
Mm.
like you say.
Uh-huh.
It becomes almost, you've got to eat the elephant one piece at a time, as many people say. But start somewhere is what you're saying, right? And start with the basics, and eventually you'll start building momentum, right? And it starts becoming a virtuous cycle almost, right? And you start building on improvements, and like you say, document it. Show the benefits. Document them and share that back, right? And something I spoke with a few people about now is, I think in maintenance generally we're not very good at talking about success sometimes, and I think we don't. Let's say I kind of call it internal marketing within a business, right? Not many maintenance managers get across the successes when they have gains, and don't really sell. I say sell. Because that is what ultimately what you're doing is you're selling and sharing the success of those benefits, right? And especially if you're maybe a site that is, let's say, reasonably mature, reliable, let's say, if you don't keep explaining and talking about the benefits and where you are on that journey, what I'm trying to say here is you're doing your team a disservice, right? At the end of the day, if you're not explaining and saying, hey, we found this number of issues proactively, and you've got to keep doing that repeatedly. But again, like you say, it doesn't have to be. It can be a maintenance supervisor. It can be the people within your team, and when you bring everyone together on the same page with that shared goal, you can get some great outcomes. So, no, great, Erik. I know we're running out of time. I'm going to ask maybe one last question. There's a lot of questions I've not asked. I have been massively looking forward to having you on, so I've got a lot of questions. But um, just in terms of what's been your most challenging time within maintenance and reliability? When have there been those challenging days where you maybe thought like, why am I in this industry? Talk us through maybe your challenges and when you look back and some tough times, maybe offshore. Talk us through some maybe more challenging times within the industry and how you overcome that and maybe any lessons you can share with the audience.
Hmm. So I think probably for me, the most challenging time would have been in the Philippines with that offshore platform. We had an asset where we had um, really quite a lot of very serious integrity and reliability issues, leading to quite a lot of stress on my side. And reliability and loss of production, and we're talking millions of dollars a day, is one thing. But we also had serious integrity issues. We had a lot of gas leaks, and we had one very serious gas leak, which we were very lucky it didn't ignite. And so that led to me being pretty, yeah, feeling very exposed, very stressed. Because you've got 60 people on that platform, and if things go wrong, then there's 60 lives at risk, right? Not, I was a relatively, I was not at the top of the organization, not at all. But one of the things that probably, looking back, what bothered me the most was that um, not everybody, in my view, at that time was taking it as serious as they should. So that was a pretty tough time. Um, what would I do different going forward? Probably to actually be two things: be more open with that, and particularly also actually try and find somebody who can act as a mentor when you're sitting in a tough period in your career. It is good to have somebody on your side who's been there, done that, and can help you either put things in perspective or say, yeah, you're right, this is a shitty situation. Here's how I would recommend you deal with it, or whatever. Right? I didn't have that. And so I think, yeah, that made it certainly a lot tougher than it had to be. I learned a tremendous amount from the year and a half or 2 years, well, probably a bit more than 2 years actually, that I was in that role. But it was pretty stressful. Yeah.
Yeah, brilliant. Great example. And like you say, I think importance of mentors. It can be challenging, right? Like you say, to find someone that can again put
Yes.
things into perspective, like you say, which is a great takeaway. Um, Erik, we've come to time. I know you're a busy man, so again, massive thank you for coming on. Again, I
Thank you for having
appreciate,
me.
you've been a mentor to me from afar over the past year. So again, just want to say thank you. You've been supportive and very generous with your time today. So yeah, wish you all the best. I know you're busy in your business, and I wish you all the success in the future. But fantastic to have you on, and I really appreciate your time.
Well, thank you, Joe. It was great to be on, and I look forward to seeing the episode and seeing more of your other episodes coming up. So good
Brilliant.
luck with it.
Thanks,
Thank you.
Erik.